Okay, welcome back to another Calculus 3 review in preparation for ASEN 3111 Aerodynamics Exam 1. Today or I guess it's all the same night. It's all like midnight on Tuesday before your exam, so you're welcome, everyone. Today we're talking about Stokes Divergence and Gradients Theorem, and these are really nifty, super helpful. I'll write helpful. That's how much I think these are helpful, because they let you take advantage of closed integrals, and it lets you kind of move between 2D and 3D integrals and 1D and 2D integrals, right? So there's usually a simpler of the two integrals. If you have a closed line integral versus a surface integral, one of those is probably a little easier to do, right? And you want to do the easier one. That's what these theorems let us do. Right, so I won't go too deep into these, just know that these are some mathematical tools that can be really helpful. So we'll start with divergence theorem, where if we have a closed surface integral of the vector field A dot of ds, right? So this is how much A is going in the direction of the outer direction of some surface, right? So if we have we'll draw a little bean again. Well, that's not really beanie. Bean, right? And it's got some surface. There's some normal area ds. Our vector field aligns with like this or something like that. We have an integral set up like this. We can do something very nifty where we just take the volume integral, right? Because this closed volume integral doesn't make a lot of sense because it's always closed. But volume integral of the gradient. Sorry, not the gradient, the divergence of this vector field, right? And this kind of makes sense. We're basically, in both of these, we're saying how much of this field is moving out of this surface, right? Because this, we talked about it in the divergence gradient and curl video. This is like, how much is this field spreading out, right? And if it's spreading out over this volume, throughout this volume, we're essentially saying the same thing as how much of it is moving through this surface, right, that encloses the volume, right? Very helpful, very useful. Definitely put it on your crib sheet. Next, we'll talk about Stokes Theorem, right? And with Stokes Theorem, we're doing a similar thing. We're going from a closed line integral, right? So this is something like this. Oops, that's the wrong direction. Something like this, right? This is some curve C, and it contains this surface S, right? We can take advantage of the fact that there are kind of two entities here, a curve and a surface, and we can go over and we can say this is the same as if we had an open surface integral over the surface S of the curl of the vector field dotted with ds, right? Another nifty one, a lot of times this is the kind of thing where it'll be a curl of like a velocity field, right? That's the vorticity. And if maybe you made some assumptions earlier, you said, oh, this is an irrotational flow. It's not twisting at all. That's equal to 0. This integral is equal to 0. Why waste your time with this integral when you can just use that, right? Now, I'll delete those so you can keep those in view a little easier. You can write them down, but that's a nice thing there. Okay, gradient theorem, right? Oh, no, we'll start over again. In 3, 2, 1. Okay, gradient theorem. This is the last one on our list, and this one is one of the lesser used ones, I think. I don't recall using this one very much. It might show up in some derivations, but I can't recall it being a useful tool on exam. That being said, definitely don't neglect to put this on exam. I think it's always useful to have a few extra equations like this, but this basically takes us from a closed surface integral to a volume integral, right? Sometimes that's useful. I cannot, off the top of my head or after some searching, find a good example of where that's useful, but I'm sure it would be in an aerodynamics context. All right, so thanks for watching this video on the Stokes gradient and divergence theorems. Thanks for watching. Tune in for our next video, which surely will be coming out soon. All right.